Now let's get started with finding area of circles. From our books, we have area of a circle. They give you the formula. You will be given the formula for your end of the year test. So all we basically have to do is know how to use the formula. Now, example number 1 gives you two examples of two circles. One has a radius, one has a diameter. So for the formula for area, you guys are going to need the radius and not the diameter. So when we were dealing with circumference, you needed the diameter, but when you're dealing with area, you need the radius, okay? So you should know how to go from radius to diameter because either you're doubling it or you're dividing it by 2. Okay, so let's get some practice. Let's go over to 1A. Now, what's good about area, or even diameter for that matter, is you can type it all into your calculator and then press enter and then you're done. So for number 1, this radius is 11 meters. So if area equals pi r squared, I'm just going to enter those numbers into my calculator like this. Well, I'm not going to put the a in there, but I'm going to press the pi button. I'm going to press multiply, and then I'm going to press 11, press multiply again, and press 11. Guys, that's the easiest way, I believe, to use these calculators that you guys have in the class. You can push, you can even do pi times 11 squared. You can also do that, but I just feel that it's faster if you do pi times 11 times 11. For some reason, it just goes faster. Anyway, once you press, put that into the calculator, you will get the area of meters squared. Okay? So then the extra step that we have to do in part B is actually take 8.2 and divide it by 2 to find the radius. Okay? So the diameter is 8.2. So divide that by 2 to find the radius. That's going to be 4.1 inches. And then so in your calculator, just put in pi times 4.1 times 4.1, or you can use the square. It doesn't matter. You're going to get the same answer. So that's 52.8 inches squared. Do not forget your units, inches squared, because we're dealing with area. Okay, let's move on. So now you're getting into real-world situations where you're not going to be dealing with the whole circle. Okay, right here they're dealing with half of a circle. So basically you pretty much just find the area of the circle, and then at the end you just take half of it. Okay, easier said. Hopefully you'll be able to get a hold of this. Now, they show you example 2, how they're using a formula. Okay, they're taking half of pi r squared and they're actually putting half inside the formula. You can do that if you want to, or you can just remember at the end you need to take half of it. Okay, so let's go down to the got it questions. The tabletop shows a radius of 1.5 feet. What is the area of the tabletop to the nearest tenth? Again, using your calculator, we're going to find the actual area of the whole entire table. Okay, and then just take half of it. So the easiest way to do that is just to do this in your calculator and then press enter. And then once you press enter, okay, then divide by 2. Okay, that would be the easiest and fastest way, I believe, with these calculators that we have in our classrooms. So you should get the answer 3.5 feet squared. All right. The additional step in 2B is that they give you the diameter. So go ahead and cut 14 in half to get the radius, and that's going to be 7. So in your calculators, let's just go ahead and put, I'm going to go over here. So pi r squared, or 7 times 7, which is 49. So you can actually easily do that in your head. So you can push this into the calculator, and then after you push enter, don't forget to divide by 2 because we're dealing with half a circle. Once all the calculations are done, the semicircle patio you should have gotten a 77 feet squared. Okay, so in example 3, now you're starting to get into situations where you have shapes within shapes. So here you have a circle within a rectangle. If you read the question, it's asking you pretty much to find the neutral zone without the circle. So we're going to find the area of the rectangle, but then you have to minus the area of the circle in order to figure out, that whole shaded blue area. Now, what is advanced here, okay, is being able to represent this whole entire problem with an equation or with an expression. And that's why they go into showing you all this work of how to actually represent it with, okay, an actual expression, because sometimes on your end of the year tests or with constructed responses, they ask you, how would you represent this real world information or this real world problem with an expression? And that's why your book always gives you that option, okay, to show you with an expression. So we're going to find the area of the rectangle, which is how you find length times width. And then we're going to subtract the area of a circle. Area of a circle is pi r squared. So that's where they get those formulas from. So you see the results of example 3. Now let's do our own example. Let's do the got it question number 3. Go ahead and read it to yourself. Set it up, and then push play when you're ready to. I'll do it with you. Okay, so for number 3, I went ahead and drew a picture of the face-off circle, including the red spot in the middle. So let's go ahead and try to represent this with an equation. So we've got two circles, so we're going to use the formula of the two circles. Notice that they give the diameter, okay? So we're actually going to have to find the radius, but that does not have to be included with our representation of an expression, okay? So we're going to find the area of the big face-off circle, which is pi r squared, okay? And then we're going to minus the smaller circle, which is pi r squared. Even though this looks like it would cancel each other out because we're subtracting both the same formulas, hey, what do you know? That's what we got to do. Okay, so let's find the area of the big circle. So if we just put in half of 30 is 15. So we're going to put in pi 15 squared minus half of 2 is 1. So that's going to be pi 1 squared. Okay, now we can just solve our calculations into our calculator. So I would press this and then press enter and get that result. And then 1 squared times 1, that's just going to be pi. So pi times 15 squared, that's going to give you about this, and then of course you have your pi button. Okay, so using 706.86 minus your pi, and you're going to get an answer of about 703.7 feet squared is the area around the red dot in the middle. Go ahead and do 1, 2, 3, 4, and 5 quickly on your own just by using your calculators. Okay, don't forget number 2, you have the diameter. Number 3, you have the diameter. And of course, number 5, you have the diameter. When you're done with those, press resume play, and I will go with number 6. I'll go for number 6, number 7 with you. Okay, before you get all happy-go-lucky and checking your answers for 1 through 5, let me show you something because we're going to be covering this later. Notice how I put my answer, or I didn't put the answer. If you look at number 1, I left it as 49 pi. And then number 2, I left it as 4 pi. Number 3, I left it as 42.25 pi. All I did was square the radius. And I left my answer in terms of pi. So sometimes in high school or maybe in the depending on your teacher in the 8th grade, they will ask you to leave your answer in terms of pi instead of rounding to the nearest tenth. This is what that looks like. So basically, it's eliminating the step of multiplying by pi. So you're left with the answer within pi. Okay, we're going to be coming back to this later, and I just wanted you guys to see the reference. But pause your video, and then as soon as you push play again, your answers will appear. Just kidding. You technically didn't have to push pause and play again. I made them disappear just like that, or made them appear just like that. Anyway, so check your answers for 1, 2, 3, 4, and 5. Make any corrections that you might need to make to your problems, and then let's work on number 6 and 7. If you need to, press pause on the video so you can make sure you get your answers. Otherwise, I'm moving ahead. For number 6, you have the picture to the right that shows you the radius in which the camera, okay, on the corner of this looks like might be a building or a house or something like that, can detect motion. So obviously what we're going to do is we're going to find the area of the circle, but we're then after that going to multiply by 3/4 because that's the area in which it does cover. Okay, if it asked you for the area in which it does not cover, that's when we would multiply by the 1/4. So your radius right here is 20 feet. So we're just going to put that in the calculator because we're not going to leave our answer in terms of pi. We're actually going to solve it. So once you get that answer, then you're going to multiply by 3/4. Okay, and then press enter. I'm giving you guys enough time to get the answer. Do you have it yet? I'm guessing you do because I'm writing down the answer. 942.5 feet squared is the area that the camera can detect motion. All right, down number 7. So we're talking about donuts. So the actual donut is 8 centimeters wide. The hole in the middle is 3 centimeters wide. So basically, they gave you the diameter. I wrote down half the diameter, which is the radius, so that we can take the bigger circle and minus the smaller circle in the middle. So we are going to take this formula again that we used before. So we're going to take the bigger one, and we're going to take pi times 4 times 4, which is 16 pi. And we're going to subtract pi times 1.5 times 1.5. Don't get your decimals mixed up with those multiplication symbols. It actually, 1.5 times 1.5 is 2.25. Okay, so now all we have to do is in our calculators take 16 times pi and then put that number down and then minus 2.25 pi. All right. So we get 16 times pi as roughly 50.27, and then 2.25 times pi is roughly 7.07. So after we subtract that, we should get an answer about 43.2 centimeters squared. Make sure you do your textbook pages next. You only have 5 problems. However, number 19 and 20 is a circle or another figure within a figure. But 21, 22, and 23, you're going to have to go the opposite because you're going to be given either the circumference or the area, and you're going to have to find the radius or the diameter. Good luck.